Hello and welcome to another video over Algebra 2. This is section 4 and this is a section about adding and subtracting rational expressions. So again, a rational expression, again guys, is a fraction. Okay, and according to me, fractions are your friend. Okay, they're not going to leave you on a Friday night. They're always going to be there for you, even when someone says they're going to hang out and then they say that, their wife and their kid are more important than, their weird, coworker. So, I digress. But these are fractions, okay? So adding and subtracting fractions, okay, but using algebra. Okay, so before we, get into the algebra aspect of doing something like this, let's go back and let's talk about adding and subtracting fractions, okay? So the first thing I want to do is, when we add fractions, we want a common denominator. Okay, so let's say that you have like 3/7 plus 2/7, okay? Because you have a common denominator, your denominator is the part that's down below, okay? Then you can write this as 3 plus 2 all over 7, okay? And that's the idea, is that, when you have a common denominator, you keep your denominator and you add your numerators. Okay, and that's going to give you 5 over 7. Okay, same thing would work if you had, say, if you were subtracting those two numbers, 3/7 minus 2/7, then, that's just taking your numerators and subtracting them all over your common denominator, and that's just going to give you 1/7, okay? So then let's take a look at something where you have, say, something like this, where you don't have common denominators. And so when I look at, say, a number like, 1/6 plus 2/3, okay? Now what I notice is that my denominators are not the same, okay? But I do notice that 3 is a factor of 6. So what I can do is I can multiply 3 by a number and turn it into 6, okay? And so that number is going to be 2. Now, whatever I do to the denominator, I also have to do to the numerator, okay? So this is going to give me 1/6 plus 4/6, okay? And now that I have a common denominator, I can rewrite that as 1 plus 4 all over 6, and that's going to give me 5/6. Okay, same thing if you were subtracting these two numbers, okay? If you had, say, 1/6 minus 2/3, okay, you need to get a common denominator. All right, 3, I can multiply 3 by a number to get 6. So I'm going to multiply that again by 2 over 2, and so I get 1/6 minus 4/6, okay? And that's just going to give me 1/6 minus 4/6 is going to give me 1 minus 4 over 6, which ends up giving me negative 3/6, okay, which can be simplified down to negative 1/2, okay, and that's the idea. Okay, what if you have two numbers that really aren't similar at all? Let's say you have 1/3 plus 1/4. Okay, now the problem with these numbers is that, 3 and 4, 3 is not a factor of 4. Okay, I can't multiply a number by 3 to get 4. And so what the trick is, when you have numbers like these that aren't factors of each other, you simply multiply this fraction by the other's denominator. So take this denominator, multiply top and bottom over here, and then similarly over here, with 1/4, okay, with 1/3, I'm going to multiply that by 4 over 4. So 4 over 4. Okay, and as a result, you're going to get 4 over 12 plus 3 over 12. Okay, and then you can write, since you have a common denominator, you can write this as 4 plus 3 all over 12, which gives you 7/12. Okay, now just for giggles, let's say that we're subtracting these numbers, so let's do 1/3 minus 1/4. Okay, and so same thing. I'm going to multiply this by 4 over 4, and this one by 3 over 3, and that's just going to give me, what's it going to give me? 4/12 minus 3/12, which is going to give me 1/12. Okay, so adding and subtracting are pretty much the same, but we got to make sure we understand how to get common denominators, okay? Sometimes you can do this stuff in your head, but otherwise I would recommend to write it out, okay? So let's go ahead and talk about this. Now, we're subtracting rational expressions with common denominators, okay? So what I look for is I say, okay, my denominator here is x squared minus 2x minus 3. Same thing here. My denominator is x squared minus 2x minus 3. So what I would do is I would then just say, all right, well, this is just going to give me 2x minus 2, minus negative 2 all over my common denominator, which is x squared minus 2x minus 3. Okay, and then what I end up getting here is I end up getting 2x plus 2 all over x squared minus 2x minus 3. Now from here, okay, what I want to do is we want to, subtract them, but we also want to simplify our fractions or rational expressions. So what I'm going to do is I'm going to factor my denominator. Okay, and I have to think. Two numbers that multiply to negative 3 but add to negative 2. And that's going to give me negative 3 and positive 1. So I get x plus 1 times x minus 3. Okay? Now my numerator up here, I can factor out a 2. So check this out. If I factor out a 2, I'm left with x plus 1. And so then what I notice is I have a common factor in my numerator of x plus 1 and a common factor in my denominator of x plus 1, and these can divide out. So therefore, my final answer, once I've simplified, is just going to be 2 over x minus 3. Okay? So that's the idea. Sometimes, and it kind of just depends on your problem, like because this one, we had a common denominator. I didn't factor until the very end, okay? So, well, let's talk about something where we have unlike denominators, okay? Such as this one. Now, what I notice is that I have x squared down here in my denominator here, and I have x squared plus 1. Now, x squared plus 1 I cannot factor, okay? And neither can I factor x squared. So because these don't have any common factors, all right, what I want to do is, and we have two completely unlike denominators, I'm going to multiply this entire fraction by x squared over x squared. Okay? And then I'm going to multiply this entire fraction over here by x squared plus 1 over x squared plus 1. Okay? Now what I'm going to do in my next step is just kind of write it out. And let me do this. Okay, I'm going to do 4 times x squared plus 1, okay, over x squared times x squared plus 1, okay? And I'm just doing the math here, okay? And then I'm going to do plus 5 times x squared over x squared times x squared plus 1, okay? Now, I'm not going to multiply this stuff out in my denominator. I'm going to leave it as is, okay? And what I'm going to do is now that I have a common denominator, I'm going to write this stuff out over a common denominator. So I've got 4 times x squared plus 1 plus 5x squared, okay? And this is all over x squared times x squared plus 1, okay? Now, to simplify this, now we need to simplify. So what I'm going to do is I'm going to take the 4 and distribute it here. So I'm going to get in my next step, and let me write that up here, okay? I've got 4x squared plus 4 plus 5x squared. Okay, I'm going to add all those up, and I'm going to divide that by my common denominator, which is x squared times x squared plus 1. Okay, so now, all right, what I have here, I'm going to combine my like terms in my numerator. a 4x squared and 5x squared. And so that's going to give me 9x squared plus 4. And then this is all over x squared times x squared plus 1. Okay, and this is my simplified version, okay? Now, what you could do, I would accept this. I would totally accept this as an answer. They might want you to redistribute this x squared down here, okay? But it kind of just depends on the answer, okay? So this would be fine. This is your answer, okay? But if they're, depending on what they want, if they want you to remultiply that back through, you could write this as 9x squared plus 4 over x to the 4th plus x squared, okay? And you could write it like that, okay? These are the same thing, just kind of depends on how you want to write your answer, okay? I'm rather indifferent. I prefer, I would just leave it as this, okay? I wouldn't mess with that, but kind of just depends, okay? All right, so let's take a look at the next page. All right, so let's take a look at another example of subtracting rational expressions with unlike denominators. So the first thing that I'm going to do is, I notice that I have completely unlike denominators, okay? But what I want to do is I want to factor these before I do anything, okay? That's the trick. We always factor before we do anything. All right, so I've got 3 over, okay, so let's do this. Two numbers that multiply to negative 10 but add to negative 3, and that'd be negative 5 and positive 2. So this is going to factor out to x minus 5 times x plus 2, okay? And then I'm going to subtract, and this is going to be 1 over, and we're going to do, okay, two numbers that multiply to positive 5 but add to negative 6. And so that's going to give me x minus 5 and then x minus 1, okay? Now notice that we have a common x minus 5 factor, okay? So what I want to do is I want to get common everything, okay? I want to get a common denominator. So I'm going to take this x minus 2 factor, and I'm going to multiply that over here because I need to combine those. So I take whatever factor I don't have over here, okay, which it doesn't match up. So I'm going to multiply this term here by x plus 2. So I'm going to do x plus 2 over x plus 2. Okay? And then on the other side over here, okay, I'm going to take, I'm missing an x minus 1 factor on this side. So I'm going to multiply this one by x minus 1 and this by x minus 1. Okay? So now, let's take a look at what we've got. All right? So on this one, and let me write this as, I'm going to do 3 times x minus 1 all over x minus 1 times x minus 5 times x plus 2, okay? And then minus 1 times x plus 2 all over x minus 5 times x minus 1 times x plus 2, okay? So what you notice here, once you factor these and you realize what you have in common versus what you don't have in common, multiply the other side by the one that you need to make sure that you have all three of the same factors, okay? So I have x minus 5, x minus 5, x minus 1, x minus 1, x plus 2, x plus 2. So now that I have common denominators, what I can do is I can write all this as one fraction, okay? And I'm going to do 3 times x minus 1 minus 1 times x plus 2. Okay, and this is all going to be over the common denominator of x minus 1, x minus 5, and x plus 2. Okay, so now let's take a look at what we have. Let me distribute my 3 here, and let me distribute my negative 1 as well. Okay, so let's take a look at what we get from doing that. Let me zoom out a little bit and write up here. All right, so I've got 3 times x minus 1, which is going to just give me 3x minus 3 up top. Okay, and so then on the next part, it's really important when you subtract here, when you subtract like a quantity in your numerator, that you distribute that negative, and that's kind of why I write all this stuff out and keep that 1 there, is because we're going to have to distribute that negative. So this is going to give me a minus x minus 2, minus x minus 2, and then this is all over x minus 1 times x minus 5 times x plus 2, okay? And so from there, okay, what I have is I have 3x. I'm going to combine my like terms in my numerator. I've got 3x minus an x, and I've got negative 3 minus 2. So 3x minus an x is just going to give me 2x, and then negative 3 minus 2 is minus 5, and then this is all over x minus 1 times x minus 5 times x plus 2. Okay, and then you'd look to see, all right, once you combine your terms up here, your like terms, can I factor anything out and will it divide out? And in this case, no. Okay, 2 and 5, I can't factor anything out of that, so I can't do anything and can't divide anything out. So that is my final answer, okay? So it is a bit tedious, but it is important that we know how to do this, all right? Oh, yeah. Okay, so on this one, okay, this is where it gets a little tricky. Complex fractions involving addition and subtraction. So remember that you have, in this, you have, what's it called? You have incepted fractions, okay? I have 2 fractions I'm adding together in my numerator, and then I have 2 fractions that I'm adding together in my denominator. So what I'm going to do is I need to look at each of these separately. Okay, so I'm going to put a parenthesis around these 2 and a parenthesis around these 2. Now what I want to do is turn my numerator into 1 fraction. Okay, so what I'm going to do, because I have 2 complete opposite denominators, I'm going to multiply this one by x over x and multiply this one by y over y. Okay, and then, okay, same thing over here. I'm going to multiply this one by x over x. I'm going to multiply this one by y over y. Okay, so the next step that I would have here would be I would have 2y over xy, x times y, plus 3x over x times y. Okay, and then I would divide that whole thing by negative 5y over xy plus 7x over xy, okay? And so what I can do now is I want to, I still have my numerator, okay, and then my denominator. Because I have a common denominator within my numerator, I can write this as 1 fraction, okay? So I'm going to come up here, I'm going to write this, and I'm going to say, okay, this is really just going to say 2y plus 3x all over xy, okay? And that's my numerator, okay? And then we're dividing that by our denominator, which is going to be negative 5y plus 7x, all divided by xy, okay? Now, when we're dividing fractions, remember, we multiply by the reciprocal. So you can write it out like this. The next step would be 2y plus 3x, all divided by xy, divided by negative 5y plus 7x, all divided by xy. Okay, and if I'm operating with this, okay, then I'm going to multiply by the reciprocal. I need to flip this fraction. So my next step would be 2y plus 3x over xy times xy divided by negative 5y plus 7x. Okay, and then what we have here is we have a common factor of xy. And what I can do is I can then divide out my xy's. And then I'm left with just 2y plus 3x over 1 times 1 over negative 5y plus 7x. Okay, and I can just multiply across and get 1 fraction out of this, which is going to give me 2y plus 3x all over negative 5y plus 7x. And that, my friends, is the answer. Now, the reality is I can't factor anything out of my numerator, nor can I factor anything out of my denominator. So if you can't factor anything out, you're done, okay? And that's your answer, okay? So it is kind of tricky. And it is, a lot of work and a lot of writing, but, there is a process to it. Okay, it's just like adding fractions with, with numbers, but instead we got to make that jump to algebraic expressions. Okay, but make sure you know how to factor, make sure you understand what a common denominator is. Okay, I would rewatch this video if you're going to have trouble with it. Okay, but you know what? This is fun because fractions are fun. And we're having fun, and that is non-negotiable.